All right, homework day 18. We're going to start by writing an equation and drawing a graph to model a real-world situation, of course, because we want to relate our math to real life. It says owners of a recreation area are filling a small pond with water. They're adding water at a rate of 35 liters per minute. There are 700 liters in the pond to start. Let W represent the amount of water in the pond in liters and T represent the number of minutes that water has been added. Write an equation relating W to T, then graph your equation using the axis below. So when it says write an equation relating W to T, it means you're going to have an equation that says W equals something. By the way, this is case sensitive, so you got to use a capital W. So we're trying to find how much water is in the pond. It says there are 700 liters in the pond to start. So we know there was 700 to begin with. They are adding water, so we're going to add water, at a rate of 35 liters per minute. 35 liters per minute. T is the number of minutes. So to show 35 every minute, we would have 35 T. So 700 to start plus 35 liters per minute. Now we want to graph that. So when we're making our table, this is like my x-axis and this is like my y-axis. So I am going to plug numbers in for the t, the horizontal axis, and my answers are going to be the w, the vertical axis, right? Just like we do x and y. If I'm going to run my water, and I just want to use nice easy numbers, notice this only goes from 0 to 10. So I'm going to use numbers like 0. 0 is easy to do. If I don't run the water any extra minutes, I just have the 700 liters that I started with. Maybe I want to say that I ran the water for 2 minutes. Well, 35 times 2 would be 70 plus the 700, so 770. Maybe I ran the water for 5 minutes. I would start and I'd first of all have to do 35 times 5. I don't know that in my head. 35 times 5 is 175. Plus my 700 would be 875. Now I only need 2 or 3 points to draw my line, but just for fun, let's do 10 minutes because 10 is easy to do. 35 times 10 is 350. 350 plus 700, 1,050. Now you'll notice when you go to plot these, 0, 700 you can put on there nice, but the rest don't come out very nice. You have to use that plot point tool. Looks sort of like this, and when you click on it, it says plot a point anywhere, and you have to type in your ordered pair, 2 and 770, and the computer will put it on there. I'm just going to estimate 2 and 770. Well, it's a little bit under 800. 5 and 875 would be not quite up to 900. 10 and 1,050 would be just barely over that. And so I should be able to connect my dots. And if I could draw straight, draw my line. Again, I like to do at least 3 points. You can draw a line with only 2 if you had to. But just pick some nice easy numbers that go along with what your graph says here. Number 2 says the Sugar Sweet Company is going to transport its sugar to market. It will cost $3,750 to rent trucks, and it will cost, should say cost there, an additional $125 for each ton of sugar transported. Let C represent the total cost in dollars and S represent the amount of sugar in tons transported. Write an equation relating C to S. So again, relating C to S means I'm going to have C equals something with my S in it. The S is representing the amount of sugar in tons. So it tells me up on that first part, it is going to cost me $3,750 to rent the truck, and an additional $125 for each ton of sugar. Try to make my S look like an S and not like a 5. So again, when I make my table, My horizontal axis is the one I'm going to plug numbers in for. So I'm putting numbers in for the S. My answers are the C's. If I don't transport any sugar, S is 0. I still have to pay the $37.50 to rent the trucks. If I want to transport, let's say 5, it's right in the middle. 5 tons of sugar. I have to take 125 times 5. 125 times 5 is 625. 625 plus my $37.50 is $43.75. If I want to do 10, just add a 0 to the 125, so 1,250. So I'm going to take my 1,250 plus my $37.50, and I'm going to get 5,000. And then I have some points. Again, I probably have to use the plot point anywhere. I'm just going to estimate 0 and $37.50 would be about halfway between 3,500 and 4,000. 5 and $43.75. $43.75 would be a little closer to 4,500. And 10 and 5,000, that one I should know exactly where that one is, so that hopefully when I connect my dots, I can draw my line. Going to look something sort of like that. I'm going to fix my typo here quick. Now number 3 is a tricky one, and that's why I wanted to put this example on here. It says a cookie company uses 1 cup of sugar for every 30 cookies it makes. 1 cup of sugar for every 30 cookies it makes. 1 out of 30. Let S represent the total number of cups of sugar. Let N represent the number of cookies. Write your equation relating S to N. How much sugar am I going to use if I have so many cookies? Well, here's the key part. 1 cup of sugar for every 30 cookies, I'm going to make N cookies. If I multiply this together, I'm going to get 1N or N over 30. So when it uses a phrase like 1 for every, tells me I'm going to end up dividing 1 out of every 30. Now I want to use N and S. Now look at the values here. We want values that make sense, and notice it's not going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We want things that make sense. If I don't make any cookies, how much sugar am I going to use? Well, 0 divided by 30 is still 0. Since this has to be divisible by 30, what if I made 60 cookies? If I made 60 cookies, 60 divided by 30 means I'd use 2 cups of sugar. What if I use 120? If I make 120 cookies, 120 divided by 30 means I'm going to use 4 cups of sugar. So my table would look something like that. 0, 0, 60 with 2 cups of sugar, 120 with 4 cups of sugar. Connect my dots and draw my line. So watch for that when it says 1 for every. I'm going to be doing something like that. Number 4 says it's about the vertical line test. I don't think I can quite get that whole page on there, but we'll talk about the vertical line test. It says for each relation below, state whether it is a function or not. In order to be a function, it says every element in the domain. The domain. Those are your x values. Right? We talked about domain and range. For every element in the domain, you can only have one element in the range, the y values. So they say you can do the vertical line test because a vertical line gives you the x values. If I happen to use the x value of 1 and I drew my vertical line right here, how many points does it touch? Well, it just touches 1 point. If anywhere on my graph I can draw a line and only touch 1 point at a time, it is going to be a function. So yes, this is going to be a function because if I draw my vertical line, I'm only touching 1 point in my range. Here, if I draw my vertical line, here I'm only touching once, here I'm only touching once. Yes, that is going to be a function. If I look at the next two, here, if I draw my vertical line, if I draw it here, it touches once, here once, so forth, all the way through my graph, any vertical line only touches 1 dot at a time. Yes, that is going to be a function. Now if I go over here and I draw my vertical line right there, it's touching 1, 2 places. That is not a function because here at x equals, if I'm close to 1/2, I've got 2 different y values. I've got 2 different elements in my range. So if I can draw any vertical line that touches the graph more than once, it's not going to be a function. I got to move that up. And look at the next two then. So here's what I'm looking for at my graph. Is there any place where I draw a line that I touch more than 1 time? This one touched 3 times. Not going to be a function because in order to be a function, I can only touch 1 point at a time. Here, if I look at my graph, if I draw my line right here, again, I touch 2 times, not going to be a function. Of course, they give us lots of examples here. If we go to number 5, we get to do 6 more of them. So number 5, we want to decide if it's a function or not. So I'm going to draw my vertical line. Only touches my graph once. Yes, it is a function. I draw a vertical line here. Oops, I can hit it 2 times. Not going to be a function. Here, if I look, once, everywhere only touches once. Yes, it is a function. Here, if I draw my vertical line, I'm going to hit it 2 times. Not going to be a function. On this one, looking right here, if I draw my vertical line, I'm touching 1, 2, 3 places, not going to be a function. Now the last one here is kind of a tricky one because you're probably thinking, well, if I draw my line right here, I might be touching 2 places. But keep in mind, this is open. So technically, I'm not touching that point. I'm only touching this point. So that line is okay. I'm only touching once. Yes, that's going to be a function. Now, if both of these were filled in, then my answer would be no because I'd be touching both the top and the bottom. So, number 6. Go ahead, think about, do you think that's a function or not? So if I draw my line, touch twice, not a function. Look at the next one. Do you think that's a function or not? If I draw my line here, I touch twice, not a function. I've got a circle. Do you think that's a function or not? If I draw my line here, I touch twice, not a function. The next one over, is that one a function? Yes, that one's a function. Only touch once. If I could draw straight. Any line should only touch 1 point at a time. And the last 2 on here, looking at this one, is that one a function? Nope. And is this one a function? Yes. So in order to be a function, any vertical line can only touch one point at a time, because any element in the domain, my x values, can only have one answer in my range. If it's got more than one, it's not a function. So, domain and range. We just talked about domain and range a little bit. The domain are your x values. Your range are your y values. So it gives us a list of ordered pairs. We know in our ordered pairs that the first one's an x, the second one is a y. The domain is listing the x values, the range is listing the y values. We're going to put it in set notation. So when I'm doing my domain, I've got a 9, I've got a 0, I've got a -7, I've got another -7. If it's in my list once, I don't need it more than once, so I'm just going to say 9, 0, and -7. You do have to use the set notation, so make sure you put the set symbols around your answer. Your range is listing your y values. So I have a y value of -8, a y value of 9, a y value of 4, a y value of -5. None of those repeat, so I'm just going to list them all. You don't have to put them in order unless you want to. You just have to have all of them in there. So -8, 9, 4, and -5 are all your y values. Number 8 then, give the domain. Using set notation, the domain is my x values, so I've got a -5, a 9, I've got another 9, so I don't have to write it in there twice, so just -5 and 9. My range, listing my y values, so I've got a -5, I've got a 9, and I've got a -3. So -5, 9, and -3 are all my y values of those 3 points. So go ahead while I'm moving the board, try to write down what the domain in the range of number 9 is. Number 9, my domain, listing my x values. So I have a 7, I've got a -2, I've got a 7, I don't need to write it down again, and I have a 0. So 7, -2, and 0. My range, listing my y values, I've got a 6, I've got a 4, I've got a -9, and a -2. And so my range, 6, 4, -9, and -2. Domain, the x's, range, the y's. We'll talk about that more later on. Number 10, 11, and 12, tables for linear functions. I don't know why they don't do this way earlier on the pie chart, but basically all they're doing is having you evaluate this expression for these x values. For functional notation, the h of x is just like naming your graph. A lot of times when we graph, we just have y equals that. Well, the reason they use functional notation is because they might have one graph called f of x, one called g of x, one called h of x, and that way if they have 3 lines on their graph, they can label them and you know which one was which graph. So when you do functional notation, you're really not doing much with this side. What you're doing is saying, okay, if h is -4, that's the value I'm going to use for x. I'm going to do 4 times -4 plus 5. I'm really not working anything out here. It's just telling me what I use for the x. All my work is over here. I'm going to solve that side. 4 times -4 is -16. -16 plus 5 is -11. And so, when h is -4, my y answer, or my answer to my expression, is -11. Then I'm going to do the next number. So h of -2 means I'm going to do 4 times -2 plus 5. -8 plus 5 is -3. Then I have to do the next one. So now I'm going to put a 2 in there. h of 2 says I'm going to do 4 times 2 plus 5. 4 times 2 is 8. 8 plus 5 is 13. And then I'm going to do the next one. So now I'm going to put a 4 in there. h of 4 says I'm going to do 4 times, ooh, where'd my problem go? Hopefully you had those other ones written down. I'll move the board back up here. So we were on h of 4. Oh, it doesn't like me to use that black pen, I think. I better use a different color. Maybe it just wants me to go back to domain and range. Oh, now I'm cleared out altogether. I gotta get my board to work again here. Just a minute. So, h of 4, it almost looks like an h. H of 4 means I'm going to do 4 times 4 plus 5. 4 times 4 is 16. Oh, goodness. H, turn back off. H of 4 is 4 times 4 plus 5. So 16 plus 5 is 21. And then h of 5 is going to be 4 times 5 plus 5. So 20 plus 5 will give me 25. So negative 16 plus 5 was negative 11. Negative 8 plus 5 was negative 3. Positive 8 plus 5 was 13. Just in case you didn't get those filled out, but you can always go back in the video. All right, number 11. Let's see if the board wants to cooperate a little more here. This time we are going to do the function g of x equals 5x minus 2. So 5 times the x value minus 2. So g of negative 3. 5 times negative 3 minus 2. Negative 15 minus 2 would be negative 17, if I could write. Then I am going to do the next one. G of negative 1. So 5 times negative 1 minus 2. 5 times negative 1 is minus 5. Negative 5 minus 2, negative 7. Then I'm going to do g of 1, putting 1 in for my x. So 5 times 1 minus 2. 5 times 1 is 5. 5 minus 2 is 3. I'm not going to use the black pen. I'm going to try the next one. G of 2 would be 5 times 2 minus 2. 5 times 2 is 10. 10 minus 2 would give me 8. And then I got one last one, tells me to use 5. G of 5 says 5 times 5 minus 2. So 5 times 5 is 25. 25 minus 2 is 23. So negative 17, negative 7, 3, 8, and 23. Number 12. Sometimes you have ones that look like this. F of x equals negative x plus 4. If you have trouble with that negative x, it's negative 1 times x plus 4. Right? Negative x is the same thing as negative 1 times x. So f of negative 4 means you're going to do negative 1 times negative 4 plus 4. Well, a negative times a negative makes it a positive. 4 plus 4 gives me 8. If I'm going to do negative 2, f of negative 2 means I'm going to take negative 1 times negative 2 plus 4. Again, a negative times a negative makes it a positive. 2 plus 4 is 6. Then I'm going to put a 1 in there. F of 1 means I'm going to do negative 1 times 1 plus 4. Negative times a negative is still negative. Negative 1 plus 4 is 3. Then I have to put a 4 in there. F of 4 means I'm going to do negative 1 times 4 plus 4. So negative 1 times 4 is negative 4, and negative 4 plus a 4 is 0. And then my last one, I'm going to put a 6 in there. So f of 6 means I'm going to do -1 times 6 plus 4. -6 plus 4 is -2. So I have 8, 6, 3, 0, and -2. (13, 14, 15) functional notation. Evaluating functions is given below. This function f of x is -2x cubed minus 5. G of x is -3x minus 1. It tells me to find f of -2 and g of 3. So if I'm doing f of -2, it's telling me to put that value in for x in my f function. So f of -2 says I'm going to do -2 times -2 cubed minus 5. I then have to solve that following my order of operations. So I have to do my exponents before I do any multiplying. -2 to the third power. -2 times -2 times -2 would be -8. So I have -2 times -8, which is positive 16. 16 minus 5 gives me 11. So f of -2 is equal to 11. G of 3. G of 3 tells me to put 3 in for my x values in my g function. So I'm going to take -3 times 3 minus 1. -3 times 3 is -9. -9 minus 1, -10. So G of 3 equals -10. So functional notation, just a way of telling you, like that function table, what numbers to put in for your x's, and then you're going to solve and find your answers. So here I want to do f of -3, f of -3. So I'm going to do f of -3. I've got x's in 2 spots. That means I'm going to put the -3 in both of those spots. So I'm going to do 3 times -3 squared, 3 times -3 squared, minus 3 times -3 on the end. So following my order of operations, I've got to do my squaring first. -3 times -3 is a positive 9. 3 times 9 is 27. -3 times -3 is a positive 9. So now I have 27 plus 9, which is 36. G of -6 says I'm going to put -6 into my g expression. So G of -6 says I'm going to do 2 times -6 minus 1. 2 times -6 is -12. -12 minus 1 gives me -13. Number 15, again, functional notation. I'm doing f of -2. So f of -2 says I'm going to take 3 times -2 cubed plus 5, putting -2 in for my x there in my f expression. Again, following my order of operations, I've got to do the cubing first. -2 cubed is -8. 3 times -8 would be -24. -24 plus 5, looks like I'm going to end up with -19. And then I'm going to do G of 5. So G of 5 says I'm going to take -4 times 5 plus 4. -4 times 5 is -20. A -20 plus 4 is going to give me -16. So functional notation. So now what they're trying to get across to you is something like this. I'm in functional notation. F of x is going to equal your answers, which on your graph is going to equal the y. So if they tell me here to find g of 1, g of 1 means that I have an x value of 1. I want to find the corresponding y value. So on my graph, I want to find an ordered pair that has 1, and I want to find the number that goes with that. So I look at my graph. My x-axis, here's where I equal 1, but I've got to touch my graph, so I've got to come down to this point. The coordinates of this point are at 1, -1. So -1 is going to be the answer. When x is 1, the y value is -1 to touch a point on my graph. Now, if I look at the second part, it says g of x equals -2. That tells me that the y value is -2, and I'm trying to find the x value. So I'm looking for the point that the x value is missing, but my y value is -2. So I look at my graph, y being -2 is this point right here. The coordinates of that point right there are at 0, -2. So in this case, 0 is my corresponding x value. Now sometimes you'll have more than one answer. If you do have more than one answer, you just have to find one value that works. In this case, we did just have one value that works, so we put that answer in there. So if it's in the parentheses, it's the x value and you're finding a y value. If it's on the end, it's the y value and you're finding the x value that goes with it. We'll look at the next one. So number 17 starts off with finding f of x equals 4. That means the y value is 4. I want to find the point on my graph that has a y value of 4. Now if you look at the graph, you actually have two different points. Here the y value is 4 and here the y value is 4. This point is at 0, 4. This point is at 3, 4. You only have to pick one of those values. It doesn't matter which one you pick. So you could put 0 down or you could put 3 down. Either one is going to be okay. If I'm finding f of 2, that means that's my x value. So I look at my graph. X equals 2, but I got to hit my graph, so I'm touching this point right here. The coordinates of that point are 2, 1. So 1 is going to be the value that you put in there. I'm just going to put a little note here. Pick 1 answer. Don't put them both in, just put one of them in, because it just says find one value. One last one. Using our functional notation. So if h of x equals -4, my y value is -4. On my y-axis, I'm going to go down to -4. To touch the graph, I have to go to this point here. The coordinates of that point, 1, -4. So what's my x value? It has to be 1. They're going to put it on the end. And so when y is -4, the x value is 1. And then the last one says find f of 0. That means the x value is 0. If the x value is 0, I didn't go left or right at all. That means to get to a point on my graph, I'm going to go down to that point right there, whose coordinates are 0, -2. And so the point that goes with that, when x is 0, my y value is going to be -2. So trying to get across functional notation. If h of x equals y, this is my x value, this is my y value. All right, that is the end of homework day 18.